The equation of a straight line can be written in the form y equals mx plus c, where m is the gradient and c is the y-intercept. The gradient is for every one it goes across, how much it goes up or down. So if you had a graph like this, and let's say it had a y-intercept, it crossed the y-axis at 3, and then for every one it went across, went up 2. So it would have the coordinate 1, 5 and 2, 7. So for every one it went across, it went up 2. That would mean the gradient is 2. So it would be y equals 2x plus 3. The gradient is 2 and the y-intercept is 3. If you had another graph that crossed at 2, and for every one it went across, it went up by a half. So it was 1, 2.5, and then 2, 3. So every one it went across, it went up by a half. It would have a gradient of a half. So it would be y equals a half x plus 2. The gradient is a half. Every one it goes across, it goes up half. And the y-intercept's at 2. We can find the gradient given 2 points on a line by doing the change in y divided by the change in x. So the change in the y's divided by the change in the x's. And I've put x2 and y2. That will be one set of coordinates. And x1, y1 will be the other set of coordinates. So say for this graph, we had 0, 3. And then we had 2, 7. So 2, 7 was this point up here. And 0, 3 was this point here. So we've got two sets of coordinates. We can label them x1, y1. That's one set of coordinates. x2, y2 is the other set. And then the gradient is the change in the y's. So 7 take away 3 divided by the change in the x's, 2 take away 0. 7 take away 3 is 4. 2 take away nothing is 2. 4 over 2 is 2. The gradient of that line was 2. Here's a question that says work out the gradient of the line joining the points. So we can use the gradient is the change in the y's divided by the change in the x's. So label them x1, y1, x2, y2, and just substitute them in. So it's 11 take away 5 divided by 1 take away negative 2. 11 take away 5 is 6. 1 take away a negative 2 is 3. You take away a negative, you add. 6 over 3 is 2. So it's got a gradient of 2. The second one, x1, y1, x2, y2. The gradient, y2 take away y1 over x2 take away x1. So again, we're taking away a negative. When we're taking away a negative, we add. So it's negative 3 take away 2, which is negative 5. Negative 2 take away negative 4 is negative 2 plus 4, which is 2. And we've got negative 5 over 2. We could write negative 2.5, but we can also leave it as a fraction. And part C, we've got x1, y1, x2, y2. So we've got 2a take away 7a over 3a take away a. So we've got negative 5a take away 2a. The a's can cancel out. Divide top and bottom by a. And we've just got negative 5 over 2. Here are some for you to try, so pause the video and give them a go. So again, we're just substituting in the change in y's divided by the change in x's. So label x1, y1, x2, y2, and we will have 6 take away negative 4 divided by 1 take away 3. 6 take away negative 4 is 10. 1 take away 3 is negative 2. So 10 divided by negative 2 is negative 5. For the second one, x1, y1, x2, y2. So we have negative 7 take away 2 over negative 1 take away negative 5. So that would be negative 9. And negative 1 plus 5 is 4. So I'll leave it as a fraction. And the last one, again, x1, y1, x2, y2, and substitute them in. So 4b take away 8b over 3b take away b. We've got negative 4b over 2b. The b's cancel. Negative 4 over 2 is negative 2. The line joining 3a and 6, 5 has a gradient negative 3. Work out the value of a. So again, we can just substitute into the same formula. So the gradient is the change in the y's divided by the change in the x's. We know the gradient this time, so that's negative 3 is equal to, and then we'll label x1, y1, x2, y2. Negative 3 is equal to 5 take away a divided by 6 take away 3. And 6 take away 3 is 3. Multiply both sides by 3. So negative 9 is 5 take away a. Add a to both sides. And plus 9 to both sides. So a must be 14. One for you to try. Pause the video, give it a go. So again, just substituting in. So m is 4. And we've got y2 take away y1 over x2 take away x1. 2 take away b over 3 minus 2, which is 5. So multiply both sides by 5. Add b to both sides. Take 20 away from both sides. b is negative 18. And another one, same thing. So the gradient is the change in the y's divided by the change in the x's. We've got x1, y1, x2, y2. Gradient is 3 over 2. So 3 over 2 is equal to negative 8 take away negative 5 over 1 take away c. So let's simplify that negative 8 take away negative 5 first. Negative 8 plus 5 is negative 3. And I want to get rid of these fractions. So I'm going to multiply them up. So multiply both sides by 2 and multiply both sides by 1 minus c. That will give me 3 times 1 minus c is equal to 2 negative 3's, which is negative 6. Then I'll divide both sides by 3. And plus c plus 2, c must be 3. One for you to try. Give it a go. So we've got m, x1, y1, x2, y2. So negative 2 is equal to 9 take away 5 over negative 3 take away d. So it's 4 over negative 3 take away d times both sides by negative 3 take away d. I'll expand the bracket and make everything positive. So 6 plus 2d, a negative times a negative is positive. Take away 6 and divide by 2. D is negative 1. This question says show that the points A, which is negative 1, 1, B, which is 2, 2, and C, 8, 4, are collinear. So they're on the same straight line. They're all lined up together. So A, B, and C are all lined up together on the same line. And we can show that by showing that they have the same gradient. So if A to B has the same gradient as B to C, they must be on the same straight line. They both go through B and they're going in the same direction. Or if A to B and A to C have the same gradient, they both go through A and they're going in the same direction, so they're on the same line. So we just need to work out the gradients of the parts and then we can show they're on the same line. So if we have A to B, we'll have x1, y1, x2, y2. So the gradient is the change in the y's, 2 take away 1, over the change in the x's, 2 take away negative 1, 2 take away 1 is 1, 2 take away negative 1 is 3, so the gradient of A to B is a third. Then we can do either B to C or A to C. Let's do A to C. So we'll have x1, y1 again, and this time it's x2, y2. So the gradient of A to C is going to be 4 take away 1 over 8 take away negative 1, which is 3 over 9, which is the same as a third. So they're on the same straight line, same gradient, and they both go through A. Therefore, they must be on the same straight line. Here's one for you to try, so give that one a go. So again, we just need to show that two parts of this line have got the same gradient. So if we go for A to B again, so that'd be x1, y1, x2, y2, the gradient, changing the y's, which is 3 minus 11, over the change in the x's, 1 take away negative 1. Negative 8 over 2 is negative 4. So the gradient from A to B is negative 4. Let's go A to C again. You can do B to C as well. That would also work. So from A to C, the gradient is the change in the y's. So negative 1 take away 11 over the change in the x's. 2 take away negative 1. Negative 12 over 3, which again is negative 4. So same gradient. And they both go through A, therefore they're on the same straight line. This one says work out the gradient on y-intercept of the line 3y minus 2x plus 5 equals 0. So this line is in a different form. It's not in y equals mx plus c. You sometimes see the form ax plus by plus c equals 0, where a, b, and c are all integers. They're all whole numbers. We need to rearrange it. That means make y the subject of the formula. So we need to get y by itself. So we can plus 2x to both sides. Then take away 5 from both sides. So 3y is 2x minus 5. And then divide everything by 3. So we could write the whole side over 3. But it's better to do each term individually, because then it's in the form we want. So y equals 2/3 x minus 5/3. So it's got a gradient of 2/3 and a y-intercept of -5/3. One for you to try. So give this one a go. So again, we're making y the subject. Take away 4x from both sides. Then I'll plus 7 to both sides. And then divide every term by 2. Half every term. So y is -2x plus 7/2. So that line has got a gradient of -2 and a y-intercept of 7/2. 3.5. This one says, so we're going the other way. We've got it in the form y equals mx plus c, and we need to write it in the form ax plus by plus c equals 0, where a, b, and c are integers, whole numbers. So we've got y equals 3/2x plus 1/5. There's lots of ways of doing this. We could do it step by step. So we could multiply through by 2, double every term, and multiply through by 5 in 2 separate steps, which I'll do. But you could do it in one step by multiplying by 10. I'll just do one at a time. So I'm just going to double every term first. So if I double every term, I'll get 2y is 3x plus 2/5. Then I'm going to multiply by 5. So I'll get 10y equals 15x plus 2. So I've got rid of the fractions. I now need to get everything on the same side. So I'm just going to take 10y away from both sides. So I've got 15x. I'm going to put the y next, so minus 10y plus 2. So 15x minus 10y plus 2 equals 0. One for you to try. So give that one a go. So we want to get rid of the fractions. We can either do it in 2 steps, timesing by 4 and 3, or 1 step, which would be timesing by 12. I'll just do it in 2 steps. So 4y equals x minus 8/3, timesing everything by 4. Now timesing everything by 3. 12y equals 3x minus 8. Make it equal to 0. So just take the 12y away. 3x minus 12y minus 8 equals 0. Sketch the graph of y equals -3x plus 9, showing the points where the line crosses the axes. So it's a crosses y when x equals 0, crosses x when y equals 0, but we already know the y-intercept. So we have a y-intercept of 9. And where does it cross the x-axis? When y equals 0, we've got 0 equals negative 3x plus 9 plus 3x onto both sides. So 3x equals 9. X is 3. So it crosses x at 3. And we just draw a straight line joining up these like so. And one for you to try. So give that one a go. Sketch the graph of y equals 2x minus 5. So the y-intercept's at negative 5. The gradient's 2. So the line, for every 1 it goes across, it goes up 2. So it looks something like this. But where does it cross on the x-axis? It crosses x when y equals 0. So 0 equals 2x minus 5. Add 5 to both sides. Divide by 2. It's at 5 over 2, or 2.5. Sketch the graph of 3x plus 4y minus 9 equals 0, showing the points where the line crosses the axes. So this time it's not in the form y equals mx plus c, so it might be harder to do. We can still do crosses y when x equals 0, crosses x when y equals 0, and draw a line from there. Or we could rearrange it into the form y equals mx plus c first, which might make it easier. I'll just do crosses y when x equals 0. So when x equals 0, it crosses the y-axis. So that will be 0. So 4y minus 9 will be 0. Add 9, divide by 4. Y is 9 over 4. So it crosses y at 9 over 4. And when y equals 0, it crosses the x-axis. 3x minus 9 will be 0. Plus 9 divided by 3. X is 3. So we know where it crosses the y, where it crosses the x, and we just need to join them up with a straight line. Okay, one for you to try. So give that one a go. So we could put it in the form y equals mx plus c, or we could just substitute in x is 0 and y is 0. So if I put when y equals 0, it crosses the x-axis. That would be 2x plus 4 equals 0. X will be negative 2. And when x equals 0, we'll have negative 5y plus 4 equals 0. So 5y equals 4, plusing 5y to both sides. And then divide by 5. Y is 4/5. So we know where it crosses the y, where it crosses the x. So we can just join them up with a straight line. Like so. Find the coordinates of the point where the line y equals 2x plus 5 intersects the line 3x minus 2y minus 4 equals 0. So where two lines intersect, that's the answer to the simultaneous equations. So solve the simultaneous equations. We've got these two equations and we need to solve them. We can use the calculator for this if we get them in the right form. So if we make them something x plus something y equals something, the calculator will do it for us. Or we could use another method. So we could substitute in the y into here. So y is equal to 2x plus 5. I can substitute it in for the y here, and I'll do that, and I'll show you the calculator afterwards. So I'm changing y into 2x plus 5. So 3x minus 2y, so that's now 2x plus 5, minus 4 equals 0. 3x minus 4x minus 10 minus 4 equals 0. So collecting the like terms, negative x minus 14 is equal to 0. So x is equal to negative 14. So x is negative 14. Substitute that in. So y is equal to 2 negative 14s, 2x's, plus 5. 2 negative 14s are negative 28. Negative 28 plus 5 is negative 23. So the coordinates are negative 14, negative 23. Now let me show you this with a calculator. So I'd firstly have to rearrange them. So I want something x plus something y equals something. So if I take away 2x from both sides, I'll have minus 2x plus y is 5. And for the second one, I've got 3x minus 2y equals, plussing 4 onto both sides, equals 4. So I've got them in the right form. Then I'll pick up the calculator, menu, equation, simultaneous, 2 unknowns, and then just write them in. So negative 2x plus 1y equals 5, and 3x minus 2y is 4. Press equals, x is negative 14, y is negative 23. Okay, one for you to try. Pause the video and give it a go. So again, the coordinates where the points, the 2 lines intersect, that's the answer to the simultaneous equations. So we can substitute in the y into the second equation. So 2x plus 3 lots of negative 3x plus 1 minus 7 equals 0. So 2x minus 9x plus 3 minus 7 equals 0. That's negative 7x. Take away 4 equals 0. So plus 4 divided by negative 7. X is negative 4 over 7. And substitute in for the y. So we've got negative 3 times negative 4 sevenths plus 1. And negative times a negative is positive. We've got 12 sevenths plus 1. 12 sevenths plus another seventh is going to be 19 sevenths. So 12 sevenths plus 7 sevenths, I should have said, is 19 sevenths. So the coordinates are negative 4 over 7 and 19 over 7. And again with the calculator, so we would have plus 3x to both sides, so 3x's and 1y equal 1. 2x's and 3y's, plussing 7 to both sides, so equals 7. And we've got negative 4 sevenths for x and 19 over 7 for y.